Welcome to PGSMaths. In this video I'm going to be looking at the properties of parallel lines. Now parallel lines are two lines which will never meet. They travel in exactly the same direction and always do. This is represented by a single arrow on each line to show that they both travel in exactly the same direction. We see this in a lot of different places. One of the most common examples is on train tracks. Trains' wheels travel along the tracks. They never get any further apart. They never get closer. It'll be a little bit weird watching a train track where they suddenly both met. I'm not quite sure how a train would cope on that. But one thing this does is it keeps a certain set of properties that never change. As this train has travelled down the track, north has never changed. No matter where you are on this track, north is always pointing the same way. One thing you should start to notice is the angles that are created between the parallel lines and this arrow. If we have a look at this stage of the journey, we have these two angles here. Both angles are identical on the top track and the bottom track. If I travel further down the line, again we can see that this angle never changes. Both of these angles are created on what is called a transversal. Transversal is a line that cuts through parallel lines, and it creates special angles that sometimes match or have special rules. One of these rules is called the opposite angle, and this is the angle created on the other side of the transversal. Opposite angles are identical. Also, these two angles, which correspond to the top part of the train track, are also equal. So let's have a look at some of these key words before we have a go at solving some problems. Here's a typical diagram that you'll see when trying to deal with parallel lines. We have this angle x, and there are special properties relating to this angle that we can use to solve and find missing angles on this diagram. Just knowing one angle allows us to find any of the others. So firstly, how do we know that we're dealing with parallel lines? Well, as we mentioned, this arrow points out that this line is parallel to this line. If it had two arrows, its parallel would have two arrows on as well. But these are called parallel lines. The transversal in this case is this diagonal line that cuts through both of them and creates our angle properties. So from x we look and see that it's on this cross created between one of the lines and the transversal. It's in the top right corner or the top right quadrant of this cross. So we have another cross formed by the other parallel line and the same transversal. This top right angle is called a corresponding angle, and it's exactly the same as x. One of the other angles that could also be said to be the same as x is the one on the other side of the cross. It's exactly the same, it's just turned around 180 degrees. So it makes it the same, and therefore we call this the opposite angle. It's opposite the cross, or whenever two lines meet like this, the opposite angle is exactly the same. In a similar way, the angle opposite the corresponding angle will be the same as x. This is called an alternate angle. It's an alternate for the opposite, I suppose. It's also corresponding to the opposite angle, but it's called an alternate angle to x. It's on the alternative side, it's on the other side of the transversal. It's on the bottom instead of the top. It's on the bottom left instead of the top right. Everything about it is alternate to x, apart from it has the same value. All of these angles, the corresponding, the alternate and the opposite angles, are all equal to x. They're exactly the same angle. If you look at them, they look the same. They're all acute angles. So knowing x, we can find all four of those angles. The other two angles that we can find on here are based on straight lines. All the way across here, I have a straight line. So the angle next to x must make it add up to 180 degrees. This is called a supplementary angle. A supplementary angle supplements x to create this straight line. It's also supplementary to the opposite angle, because this is also a straight line, therefore both of these add up to 180 as well. We could also find this angle here using supplementary angles, because we know that the corresponding angle here and the one next to it add up to 180, or the alternate angle and this angle must add up to 180. The final angle that we're looking at is called co-interior. It's called this because it exists inside the two parallel lines and transversal. Inside these two angles next to each other both add up to 180 as well. We can see that because we know that x and the corresponding angle are the same, and we know that two angles on a straight line add up to 180 degrees. We could also say that the alternate and the supplementary angles are also co-interior to each other. They're both inside parallel lines on the same side as the transversal. This supplementary angle is also alternate to the co-interior. They're both the same angle. You can see they're both obtuse angles. So what you should be able to see through all of this is there are actually only two different angles created between parallel lines and the transversal. Usually there's one acute and one obtuse. It might help to actually demonstrate how we can use this then to find missing angles. On this first diagram, to find angle A, we can look and see that we have these two parallel lines. One here and one here. So if these two are both pointing in the same direction, that means that this angle line across the middle is our transversal. We know that this angle here is 125 degrees. So how can we use parallel lines to solve the two missing angles? Well, B is a very easy one. It's opposite 125. We have these two lines create a cross, so therefore we know that B is 125 degrees also. Now 125 degrees is at the top right of this cross. We also have another angle A at the top right of another cross. Therefore, because it's on the same diagram, the same set of parallel lines, this must also be 125 degrees. So what about on this diagram? Well, we have a different set of parallel lines here. These ones are pointing upwards. Now to show that there's a different set of parallel lines, I'm going to use a double set of arrows, because these two lines are definitely not parallel to these diagonal ones. Now we're given one angle here of 35 degrees, and it's our acute angle. So looking at the others, we can see all of these are obtuse, so they're definitely not 35. But angle C, we can see, is on this straight line, so therefore it's a supplementary angle. So to find out what C is, we know that supplementary angles, or angles on a straight line, add up to 180. So if we take away the 35, whatever is left over must be angle C. So angle C is worth 145 degrees. And we can prove that by saying it is supplementary. From this, we can see that E is corresponding to C, so that's also 145 degrees, and D is opposite E, so D is also 145 degrees. Make sure that you learn these words because it's very important to be able to describe the reasons behind your calculations. So the challenge of the day is quite simple. What type of triangle is this? All the facts that you need are on the diagram. You just need to give a name for the type of angle this is with proof. Leave your answers in the comment section below. Remember to subscribe for future videos and send us a message at PGSMaths on Twitter or on Facebook /PGSMaths if you have any questions, queries or suggestions for future videos.